In this video, we're going to discuss the concept of the mole fraction. So the concentration of a solution is defined as the quantitative measure of the amount of solute that is dissolved in a given amount of solvent. And there are several common ways to measure and express concentrations of a solution. Some of these, such as molarity, we're very familiar with. We also have mole fraction, mass percent, and molality are other common ways. In this video, we're going to focus on the concept called the mole fraction. So the mole fraction is abbreviated as the Greek letter chi, C-H-I, which looks kind of like an italicized X. And it's defined as the moles of one component of the solution divided by the sum of the moles of all the components of the solution. Another way to express this would be like this. If we have the mole fraction of A, would be the moles of A divided by the moles of A plus B, assuming the solution was only made up of two components. Now again, if it was made up of more, we would have the total moles of solution down here. Now the moles of A could be anything. We could measure the mole fraction of the solute or the solvent. So it's very important that you're very careful to define exactly what you're looking for. We could be looking for the mole fraction of a solute or a solvent. So again, how you define that it would be can vary. So why do we use the mole fraction instead of, say, molarity to measure the concentration of a solution? Well, mole fraction is temperature independent. So if we're dealing with experiments that have changes in temperature, we often want to use mole fraction. Another good example of when we use mole fraction is when we're measuring the concentration of a mixture or a solution of gases. Of course, with gases, you can change the volume. You can compress the solution of gases, you can expand them, and the gas mixture or solution of gases will contract or expand to fill the volume that they're given in. So it's often very useful to use a measurement like mole fraction that does not involve volume in order to measure the concentration of a solution. Also, it's often used when measuring concentrations of solutions with volatile liquids. So if we have a solution that's made up of two or more liquids, and those are volatile liquids, we want to use mole fraction. A volatile liquid is a liquid that can easily evaporate to form gases. So again, because we're forming gases, mole fraction is often used. So if we have volatile liquids, you'll see often mole fraction is a common way to measure those concentrations. So let's take a look at a very simple problem involving mole fraction. Let's say we have a mixture of gases that's composed of 2 moles of nitrogen, 3 moles of oxygen, and 4 moles of carbon dioxide. Calculate the mole fraction of oxygen in this mixture or solution of gases. So pause the video and give this one a try. Okay, so we want to measure the mole fraction of oxygen. We could measure the mole fraction of any of these. So oxygen, the mole fraction of oxygen is going to be the moles of oxygen divided by the total moles in our solution. So we have 3.00 moles of oxygen, and the total moles would be the moles of our nitrogen plus the moles of oxygen plus the moles of carbon dioxide. So we have a total of 9 moles of in our solution and 3 moles of oxygen. So simply we divide 3 moles of oxygen by the total of 9 moles. Our units cancel, so mole fraction is unitless, very important, and we end up with a mole fraction of 0.333. Okay? So essentially our mixture is about 33% oxygen by moles. So be sure that you understand the concept of mole fraction and understand when and why we use that concept.